Hello Blake and Daniel. Looks like we're ready for our next installment here of 16.4. This will be our final installment of 16.4 that we're going to be looking at. So this is just kind of more of the same. As you guys are probably figuring out, this isn't necessarily easy stuff, these surface integrals. I think probably the biggest challenge a lot of times is figuring out whether we want to use the formulas. They're included from Theorem 1. Those are the ones that are found there on, when we take a look there with Theorem 1, we find those on, they end up being from number 7, formulas number 7, or whether we want to use the ones from found there on number 9, the surface integral over a graph. Probably the best way I can tell you to know what you're going to want to do is, generally speaking, if you get something that is already parameterized in terms of just 2 variables and you don't have an equation, you don't have a function of f in terms of all 3 variables, then you're going to want to use the stuff from Theorem 1 from equation 7. If you have something that is in terms of an equation that is in terms of x, y, and z, then you're going to want to parameterize that z in terms of make it a function in terms of x and y, and then use the equation number 9. And we're going to see both examples here as we look at stuff here on today's assignment. So let's go ahead. We're going to look at 2 examples. So let's start with number 32. And notice on number 32, they're going to ask us to do a couple things. They give us a function here, g, in terms of u and v. So we see this as something that's already been parameterized in 2 variables. And so it has an x, y, and a z component, but they're parameterized with these 2 variables. And so this is going to be the type of thing where we're going to use theorem number 1. We don't have a single function in terms of x, y, and z. And so also we would know this if we take a look here. First off, we're going to ignore part A. We're not going to try to plot this. We're going to go to part B. It says calculate the normal vector n. So to do that, that tells us right away we're going to be using theorem 1. So let's go ahead, let's calculate that normal vector. In order to do that, we have to get the 2 tangent components, so then we can take a cross product. So getting the tangent with respect to u, taking the derivative here of the x component. Notice this acts as our variable term. This is our constant, so this remains the constant. Derivative of cosine of u is just going to be negative sine of u, so we have that negative sign. And then we've got our constant times our sine of u. Taking the derivative here, derivative of sine of u is cosine of u, so we simply have that 3 plus sine v times cosine of u. And v acts as a constant with a derivative with respect to u, so we just get 0. Now we'll get our tangent component for v. So once again, going through here, this becomes our variable term. This is our constant. When we take the derivative of this, the 3 is gone, and so we just get cosine of v times cosine of u. Taking the derivative here, the same basic thing is happening, only this is a constant, so we get cosine of v, sine of u. And that's hard to see there. That's actually a sine of u there. And then finally, the derivative of v is 1 with respect to v. So there's our 2 tangent components. Now we need to go ahead and set up our cross product for our normal. So here is our calculation of our cross product for our normal. It gets kind of messy. So obviously pause the video and write that down if you need to. So I just simply wrote down the different expressions here. Now let's do it. Go ahead and let's go through our cross product. So first, to get our x component of our vector here, our normal vector, we will cross here. Sorry, cross that, did the wrong one. To get our x component, we will cross here and get our 3 plus sine v cosine u minus 0. So we just get, for our x component, we just get our 3 plus sine v cosine u. Now for our y component, we will cross here and get our negative 3 sine v sine u, and when we cross there we get 0, so we just have our negative 3, and there is a negative sign missing there. It does need to have its negative. Oh, sorry, there is a negative, but then we subtract that one, that's why it's positive. I knew I paid more attention the first time I did it, I guess. Last one, we cross this up. Now we're going to have some work to do. So when we cross this here, we get negative 3 sine v, and then we get sine u times cosine v times sine u, so we get a cosine v times a sine squared u. And when we cross this way, we're going to have minus, and notice we have this 3 plus sine v times, and we're going to get a cosine v and a cosine squared u. So at this point what we can do is we can factor out, notice this minus 3 minus 3 plus sine v cosine v out of both of them. And that'll just leave us with a sine squared u plus a cosine squared u, so that just leaves us with times 1. So this just ends up being this for our normal vector. So there's your normal vector. Now from that, that's the part A. Part C, or part B, sorry. Part C says find the area. So our area formula we know is going to be the double integral over our given domain of the magnitude of our normal vector du dv. So we are going to have to calculate the magnitude of this normal vector here. That'll be our biggest challenge here. And our domain is given to us in the beginning. They say that u is between 0 to 2 pi and v is between 0 to 2 pi. So setting up our integral, we go from 0 to 2 pi, 0 to 2 pi, and now we need our magnitude of our normal vector. So our magnitude of our normal vector is going to be this squared and notice what we get. When we square this, we get a cosine squared plus, and we're going to have this squared, what we'll get a sine squared. And then we'll have this squared, and we'll get another cosine squared here. So notice we'll have this 3 plus sine v squared each time, and that negative will become positive. So I'll just factor out that 3 plus sine v squared out of each. And then what I'm left with is a cosine squared u plus a sine squared u plus a cosine squared v. Well, this cosine squared u plus sine squared u is just 1, so it's just left with a 1 plus a cosine squared v. If you have trouble seeing that, go ahead, stop the video, work it out. You can see that that's what you get. And then it's du dv. So working this here, at this point, it is a calculator problem. They don't expect us to try to integrate that. We're very thankful for that. So we simply go ahead, plug it in. They do say to go out to 4 decimal places, so we'll abide by their request. We never, if they ask us to be more accurate than 3, we'll be more accurate. So there we go. 144.01. Oh man, I ate some almonds and the husks of them are caught in my throat. Oh well. Let's go ahead. That's our one there. It's calculator 1. Now let's go ahead and let's look at 34. So 34, we're also finding area, but notice right here we've got an expression, x, y, z. Usually when we have this situation, that's a good hint to say we're going to be using that equation number 9. We're going to be having to re-express z in terms of x and y. And so we know this is going to be lying above a rectangle that's in the xy plane. And we know x is going to go from 1 to 3 and y is going to go from 2 to 5. You could sketch that if you want to, but I think you can picture that one pretty easily. That integral there in the xy plane. Or that rectangle in the xy plane. So what we're going to go ahead and do here is we are now going to first off solve for z, because remember we have to express z in terms of x and y in order to use that use the formula number 9. So solving for z, what I'm going to find here is I get z is equal to, and I'm going to have to subtract each one of these, divide through by 4, so I'm going to get a negative 1/2 x, going to get a negative 3/4 y, and going to get 28 divided by 4 to get plus 7. So that's my g of xy. That's going to be in place of my z. So now my f is not in terms of x, y, z. It is now in terms of f of x, y, and g of xy. There, as I can express z in terms of this function right here. Okay, next what I need to do then, in order to plug into that formula, since I just want area, really all I need is I know that my formula is going to simply be the area of S is going to be the integral over the domain of 1, since it's area, it's just 1 times my g partial of x squared plus g partial of y squared plus 1 dy dx, or dx dy, doesn't matter. So going ahead here, I need the partials. So finding the partial with respect to x here is just going to be negative 1/2. The partial with respect to y is going to be negative 3/4. Now with my partials in hand, I can go ahead and I can set this up. Integrate from 1 to 3 and 2 to 5. And this is going to be the square root. Notice when I square negative 1/2, I get 1/4, positive 1/4. This becomes positive 9/16. So to add these up with the 1 here, I got to change it all into 16ths. So this is 4/16 plus 9/16, 13/16 plus 16/16, so I get 29/16. Now going ahead there to do that, probably easiest just to bring this out in front. And I know that I'm going to integrate. So when I go from, I know I'm just going to get each one of these, when I integrate, this is going to go from 2 to 5 for y, so that's just going to be y. It's going to be a value of 3. It's going to go from 1 to 3 in terms of x. It's going to be 2. So we're going to get that when we integrate. Notice I do know when I take the square root here, this is going to be 4. So the 4 over the 2, or the 2 over the 4 cancel out, and just give me with radical 29 times 3 over 2. And that's my answer. Okay. Hope this goes well. I know you do have access to the solution manual. Do try to make your best effort to not rely on that solution manual, and then use it when you're truly stuck and you've exhausted things and you need to figure out what needs to go, because you're going to have to make sure you can do these without relying on the solution manual. But it is a good resource for you. Okay, here are your problems. 6.4, 31 through 39, odd. And this will finish out 16.4, and tomorrow we will begin on 16.5, our last section of chapter 16. We are making our way through the book. So hang in there. We'll probably have an extended review after we finish up with 16.5, kind of like what we did with 15. Probably take about 4 days of review. I haven't looked at it exactly, but probably that's about what we'll do. And then we'll get ready for a chapter 16 test. All right. Hope this finds you well. And I will be available to talk to you guys on a Zoom session if you need it tomorrow. All right, bye.